Good morning students, welcome to the lecture number 14 of chapter 6. In the lecture number 13 we have discussed about the theorem 6.4, and according to the theorem 6.4, if a transversal line intersect two parallel lines, then the sum of two co-interior angles, that means this angle and this angle are co-interior, so their sum is equal to 180 degree. Similarly, another pair of co-interior angles, this angle and this angle, is also 180 degree. Okay, so here it is given that this is a transversal line and it intersects two parallel lines, so that the result are their addition is 180 degree. And now we will discuss about another theorem, that is theorem number 6.5. Okay, so let us understand the statement of that theorem. According to the theorem 6.5, it is given that if a transversal line PQ intersect two lines, it is not given that these two lines are parallel. No, it is not given. It simply gives that the transversal line intersect any two lines, AB and CD. Right? It is not given that whether AB and CD are parallel or not parallel. It is not given. Okay? So that sum of co-interior angles is 180 degree. This is the condition. The condition is that whenever a transversal line intersects any two lines, then we get two pair of co-interior angles like BMN and DNM. This is one pair, and another pair is AMN and this angle CNM. So we will get two pair of co-interior angles. And according to the statement, the sum of such co-interior angle is equal to 180 degree, and these two are added to give also 180 degree. Okay, this is the condition that has been already given in the statement. Now you have to prove then two lines are parallel. So now we have to prove the line AB is parallel to the line CD. Okay, so this is the theorem number 6.5. Okay, now you remind the theorem 6.4. In 6.4 it is given that if AB and CD are parallel and PQ is a transversal line, then sum of this co-interior angle is 180 degree. Suppose this is angle 1, this is angle 2, this is angle 3, this is angle 4. Then according to the 6.4 theorem, angle 1 plus angle 2 is equal to 180 degree. We have to prove it. And angle 3 plus angle 4 is equal to 180 degree. We have to prove this. This is given and this has to prove. But in the theorem 6.5, this is given that the sum of co-interior angles is 180 degree. This is given and you have to prove the two lines are parallel. So what is the difference or what is the similarity between these two theorems? They are just complementary to each other. They are just opposite to each other or converse to each other. That is why the theorem 6.5 is known as converse theorem 6.4. Okay. And now we will prove the theorem number 6.5. So first write what is given in the statement. Okay, according to the theorem 6.5, there is a transversal line PQ, transversal line PQ intersect the line AB and CD. Intersects AB and CD at two distinct points, at M and N. Right? So we have two pair of co-interior angles formed. So two pair of co-interior angles are formed. And it is also given that the sum of this two pair of co-interior angle is equal to 180 degree. And this angle means BMN plus this angle DNM is equal to 180 degree. Okay, and these two pair angles AMN plus CNM is equal to 180. So this has been given the statement. Right. Now what we have to prove? To prove, we have to prove that this straight line and this straight lines are parallel. So AB straight line is parallel to CD straight line. Right. Now prove. How can we prove that these two straight lines are parallel? If we can prove that whenever the transversal line intersects any two lines at two distinct points, if their corresponding angles are equal, if we can show the corresponding angles are equal, then we can say yes, this line is parallel to this line. Remind the axiom number 6.4. In 6.4 we have studied that if a line intersects any two lines and if their corresponding angles are equal, then these two lines are parallel. This is the axiom number 6.4, or you can say converse axiom 6.3. Okay, so here also we need to prove that their corresponding angles are equal. If we can prove them, then we can easily say yes, these two lines are parallel. So our basic target is to show that the two pair of corresponding angles formed is equal to, or they are equal. Okay, so let's prove. Now in order to prove, we have to consider any one side of the transversal line. Suppose we consider this side. Right. Now PQ is a straight line, and on this straight line MB is a ray. Okay, so PQ is a straight line on which MB ray stands. Right. Now if on a straight line one ray stands, then it forms two angles, this angle and this angle, and these two angles are linear pair, and sum of these two angles is equal to 180 degree. So we can write this angle BMP plus this angle BMN is equal to 180 degree. Why? Because they are linear pair. This is equation number 1. Understood? Now, as it is given that this angle and this angle is equal to how much? Is equal to 180 degree. It is given in the question that this angle and this angle are co-inter angles, and sum of these two co-inter angle is equal to 180 degree. So we can write that this angle plus this angle is equal to 180 degree. So write BMN and BMN plus DNM is equal to 180 degree. Why would I write it? Because it is given. So you can write given. And this is equation 2. Understood? Now you have to compare these two equations. So compare the equation 1 and equation 2. Now you can see in equation 1 and equation 2 we have the same RHS. The RHS is 180 degree here, here also the RHS is 180 degree. And if any two equations, the one side is equal, then we can write that their other sides are also equal. So we can write the left hand side of equation 1 is equal to the left hand side of equation 2. So write it. So BMP plus BMN is equal to BMN plus DNM. Okay, so you can see in these two sides, the left hand side contains BMN and the right hand side also contains BMN angle. So what we will do? We will take this BMN to the left hand side so that these two can be cancelled out. Okay, so we get BMP plus BMN. Now when this BMN taken to the left hand side will be minus BMN. is equal to what remaining in the right hand side? D and M. Okay. So now these two are equal, so they can be cancelled out. 5 minus 5 is 0. X minus x is 0. So what we get? We get finally BMP is equal to D N and this is M. D and M. Okay, this is the final result that we get after cancelling the two terms BMN and BMN. Right? So we find BMP. BMP, that means which angle? This angle. Okay? Is equal to D and M. D and M, this angle. So we find these two angles are equal, and what are the relationship between these two angles? These two angles are known as what? They are corresponding. See, it lies towards the exterior, it lies towards the interior. Both are at the same side and they are non-adjacent. So these two angles are known as corresponding angles. And we find the two corresponding angles are equal. Okay? But these two angles are corresponding, right? And according to the axiom number 6.4, if any two corresponding angles are equal, then these two lines are parallel. Since we find that the corresponding angles are equal, so we can write hence the line AB is parallel to the line CD due to axiom 6.4. Hence it is proved. We need to prove the line AB is parallel to CD and we prove it. Okay, by using the axiom number 6.4. Right.